three planes if it exists. Interpret your results geometrically as well. So 2, 1, 0 here, because there is no Z in the second one. So look at our normals here, and I could say I don't see any scalar. Oh, no, I don't. Wait a second. 1 times 3, 2 times 3. No, I don't see any scalar multiples. So I'm going to check and see if the normals are coplanar. So we're going to do the cross product here. Start there. So downward minus upward is going to be -8. Downward minus upward is going to be +16. Downward minus upward is going to be 9. And that's not 0. It's actually -3, which means we can guarantee we have a point of intersection because the normals aren't coplanar and we have no scalar multiples. So we have to eliminate. What do you want to eliminate first?
Why not the x's?
The x's, okay. So let's use eliminate x from 1 and 2. So I mean, I'd have to multiply equation 1 by 2. So that's going to give me 2x plus 2y. 4y. Minus 6z, and that's going to be -22. So we'll bring it over and make it +22. So that's equation 1 multiplied by 2. And equation 2, we'd have 2x plus y equals 7. And in order to eliminate x, we'd have to subtract. And we're going to get 3y minus 6z equals 15. And then we'll eliminate x from. So we have to use equation 3. So we'll use 1 and 3. So that means I would have to multiply equation 1 by 3 this time. So 3x plus 6y minus 9z equals 33. So that's equation 1 multiplied by 3. And equation 3 is 3x plus 6y minus 8z equals 22. We're eliminating x, so we'll subtract. And we end up getting -9z minus -8z is -z equals 33 minus 22, which is 11. So z is -11. So that worked out nicely. Good call, John. So we were planning on just eliminating x, but because of how this system worked out, we were able to isolate z already. So now that I know z, can I come over here and find y? Because I have that equation is just in terms of y and z. So I can do 3y minus 6 times z, which is negative 11, equals 15. Which gives you negative 51. So now we know negative 17 is y, and all we have to do is find x. I think I'm going to use equation 1 because it's got just a 1 in front of the x. So this is equation 1 here. And I'm going to solve for x, knowing that y is negative 17 and z is negative 11. So that's going to be negative 34 plus 33 minus 11, negative 12. So we end up getting x is 12. So our point of intersection should be, remember to put the x first, the y second, and the z third. And then, of course, you could check it by making sure that that point satisfies all three equations using your calculator. But there's our point of intersection. Any questions for that one? Oh, we should put our little, I'm going to put a little picture on it. So I've got my point of intersection picture out here. And there we go. So that point is right in that corner there where the three planes meet. And we are done the first question. All right.
Oh, yeah.
Yeah, I know, we're getting there. Okay, second question. First normal is 1, negative 1, 1. Second normal is 1, 1, 1. Third normal is 1, negative 3, 1. And they're not scalar multiples, so now we're going to check, are the normals coplanar? So find our cross product of n2 cross n3. So it's going to be 1 minus negative 3, which is 4. 1 minus 1, which is 0. Negative 3 minus 1, which is negative 4. And then if we dot those, we're going to get 4 plus 0 minus 4, which is 0. Which means, therefore, we either have a line of intersection, we have that, this one, the star I call it, which is a line of intersection, or we have the triangle, which is no intersection of all three planes. And we also know if there is an LOI, the direction is m equals, so we did a cross product right there, but there's a smaller scalar multiple. We could use 1, 0, negative 1 and still be parallel to that cross product. So that could be our direction. And now we want to find a shared point if it exists. Among all three planes. So we want to eliminate Z this time. So eliminate Z from 1 and 2. Looks pretty easy to do.
I'm wondering for the lines of intersection, are we able to assume one that could be 0 or something?
You can.
Yeah.
Yes, you can do that. It's, you just run into more likelihood that it doesn't happen.
That doesn't happen, yeah.
Because you've got you've got all three planes.
Mm-hmm.
But
Okay.
yes, and then if it doesn't work, then you just try another one being 0, and then try the third one being 0.
Okay.
But yeah, that's also a perfectly good way to start as well, John. And it doesn't matter to me which way you go with that. So if we're eliminating Z here, we had to subtract, but the X's also eliminate. So we end up getting negative 2y equals negative 4. So we get y as a constant. So y is automatically 2 at our point of intersection. So that helps us. So what would you like to do next? Now that we know y is 2, now it's way easier. We can either let x equal 0 or z equal 0 and hope for the best. So let's let z equal 0 and eliminate x. And we'll use equation 3, so we'll eliminate x in 1 and 3. So we've got x, but remember y is now 2. So x minus 2 plus z plus 2 equals 0. That's equation 1, which I'm going to have to clean up. And equation 3 is x minus 3y, but that's 3 times 2. Plus z plus 6 equals 0. Oh, wait a sec, we let z equal 0. My bad. Oh. I was eliminating z. Yeah, we don't need to. If we let z equal 0, we can just solve for x. Yeah. Sorry, guys.
No worries. This is just the solving process of doing these questions.
It is. So if we let z equal 0, we're assuming there's a point, and then we have to go and check if there is one or not. Whereas if we don't let z equal 0, we can get that either 0 equals 0 or 0 equals a number, so we can tell the difference between triangle and line of intersection. So let's eliminate instead here. So let's eliminate. We eliminated z from 1 and 2. Let's eliminate x. I think we'll end up with 0 equals 0. Eliminate x in 1 and 3. But isn't that what we did? Yes, we would have got 0 equals 0. But I just want to show you that we do get 0 equals 0, so we know there's a line of intersection. So we're going to get x minus y, which is 2, plus z plus 2 equals 0. That's equation 1. Rewrite it as x plus z equals 0. So that's equation 1. Equation 3 is going to be x minus 3 times 2 plus z plus 6 equals 0. And that minus 6 and plus x is going to add up to 0. So we end up with equation 1 and equation 3 being the same now. So that when we subtract them, we do get the 0 equals 0. And that's what tells us there's definitely a line of intersection. So now it's safe to let x equal 0 or let z equal 0 and solve for the other of the two. Because we now know there's a line of intersection. If we tried this and got 0 equals 1 or 0 equals 4 or 0 equals 17, we would know there was no intersection and we would be done the question at this point. So I guess this is kind of, instead of checking your point satisfies all three planes, but I still do both just to make sure I haven't made a math error somewhere. So now let's let z equal 0. So now we know z is 0, y is 2, and we just need to find x. So I'm going to use equation 1. Y is 2, z is 0, and we actually get x equals 0. So if we come up here, make sure the point 0, 2, 0 is on all three planes. And such an easy point, you can probably just eyeball it. 0, 2, 0 is what we're checking. So if we look up here, x and z would be gone, so we just have -2 plus 2 is 0, because x and z are both 0. X and z both 0 here, so we'd have 2 for y minus 2 is 0. X and z both gone. -3 times 2 is -6 plus 6 is 0. So yep, it's on all three planes. So therefore the line of intersection is r equals our point we found plus parameter times our direction vector. And we'll get our picture. So that's the star, I call it. And our line of intersection would be along here. The line where all the planes meet.
So this line of intersection is basically on the XZ plane, or like,
yes,
not on
the
above the XZ plane, or parallel to it.
Parallel to the XZ plane, yes. Going through the y-axis at the point 2, right?
Mm-hmm. Yeah.
Yes.
Well, that's cool.
It is. It's great when you're comfortable enough to start to visualize what things look like, and the more you do it, the better you'll get at it. There's a course when I learned vectors, my teacher never showed us one diagram. All it was math on the board. Like, he never drew a diagram once. So I really didn't have an understanding of what any of this stuff meant. And then in a third-year course I took at university was called differential geometry, which is calculus and vectors together. And my mind just exploded because I suddenly understood what all of that stuff was. I understood what the intersection of planes looked like. I understood what projections were, all that stuff. And it was, then I really started liking it. So when I started teaching vectors, I thought, I've got to do the pictures, because I had no idea what anything was without pictures.
Well, thank you.
No problem. I was surprised that this is the first class that's liked calculus better than vectors in all the time that I've taught it. So I don't know if it's because vectors is better like live, or like vectors is easier for most people. So maybe that's why they liked it better, and this class liked the hard stuff better. So I don't know. It was interesting. I thought like my prediction was wrong. It's like now it's at about 70-30 for calculus, which is great. Oops, it looks like we've got a scalar multiple here. It looks like N2 is 2N1. So now we'll check our D's. Yep, this is all true, which means pi 1 equals pi 2. Everybody agree with that analysis there?
I accept that, yeah.
Concur? Okay, so that means we definitely have therefore a line of intersection, and we can kind of cross this plane off and just have our two-plane system now and find that line. So we want to find the direction of the line of intersection. So we need to find the cross product of the normals. So 1, -1, 1, repeat the 1. 1, 1, -1, repeat the 1. 1 minus 1 is 0. 1 minus -1 is 2. 1 minus -1 is 2 again. So I think I'll take my direction to be 0, 1, 1. Now we have to find a shared point. And we'll let z equal 0 like we normally do in these questions and see what happens. So it looks like we can easily eliminate either x or y at will here. What do we want to do? Eliminate y because we just have to add maybe? So that's going to give us 2x equals 0, or x equals 0. Find y. So let's choose equation 1 here. So we've got 0 minus y equals 2. So y is -2. So check that P0 -2, 0 is on pi 1 and pi 3. And we can do that visually again. So if you're subbing 0, -2, 0 in up here, you'd get 0 minus -2, which is 2, plus 0, 2 equals 2, we're good. 0 minus 2 is -2 minus 0. So we just have -2 on this side and that side. So it is, yep, check. So therefore, LOI is R equals our point. Make sure your x goes first. So 0, -2, 0. Plus t times our direction vector, and then find our picture. So that's going to be the one where it just looks like 2 planes, but it's really 3 because 2 of them coincide. And there's our picture. And our line of intersection is right along here.
Do they have a Desmos for 3D planes?
Not that I've seen. They have polar coordinates, but I haven't seen an X, Y, and Z. I bet you it's coming. I bet you it's in the works. It would be really useful.
Yeah. It would
There
be.
are some Java programs I've seen over the years. They aren't that easy to use, but you can see stuff. They've probably improved them a lot. I bet you by next year there probably will be Desmos in with the X, Y, and Z axes, which would be great. All right, our last question together of the year. All right, look at these normals. Oh, I see some N1 and N3. So N3 equals 2N1. So now we're going to check the D values. Not true. So that means pi 1 and pi 3 are parallel and distinct. And what can we conclude based on the fact that we know pi 1 and pi 3 are parallel and distinct?
There's going to be no point when they all three come together.
Right, no intersection of all three planes. And what picture would I choose?
I guess you could call it a sharp, not a sharp sign. I don't know. It's got the line.
This guy?
Parallel line. That one, yeah.
Okay. So we've got our two parallel planes.
Like?
This is like pi. I don't know. I don't know what to call this one. It always reminds me of when we're learning angles in grade 9 with the transversal and the two parallel lines, but in 3D. So that would be pi 1 and pi 3 would be the two parallel planes, and then pi 2 would intersect them at an angle, but there's no intersection of all three. There's nowhere you can touch where all three planes are touching at once. All right, so that is the end of grade 12 calculus and vectors, guys. I will exit out of here. And I will stop recording.